Hello students, welcome to today's lecture. So as you have already gone through that there are two methods of solving system of linear equations. First being the matrix inverse method or matrix method, and the second method is Cramer's rule or determinant method. So our today's lecture is focused on solving the system of linear equation using Cramer's rule, or sometimes known as determinant method. So how to solve using Cramer's rule or determinant method. So for instance, if we are given with the system of linear equation or matrix in the form of ax equals to b, how do you find the solution to this matrix or system of linear equations using Cramer's rule or determinant method? So in that case, what you have to do is that the first step is to find the determinant D. You have to find the determinant D of the coefficient matrix A. So once you get or compute the determinant of the coefficient matrix A, then you should check whether the determinant of this coefficient matrix A is equals to 0 or not equals to 0. So if you find that the determinant of the coefficient matrix A is not equals to 0, then we can say that system of linear equation has a unique solution. So if the unique solution exists for any particular system of linear equations, then we can find the solutions for the variables involved in the system of linear equations. Like x1 can be obtained by using the formula d1 divided by d. x2 can be obtained by using the formula d2 divided by d, and you can keep calculating the variables till you obtain the last value xn, which is equals to dn divided by d. So in these formulas, so you already know how to find d, and the next step will be how do you really obtain the values of d1, d2 and till dn. So I will explain these values or this values to obtain, how it's obtained in the example. So now we'll go through the example questions for solving system of linear equations using Cramer's rule or determinant method. So first example question will focus on solving two system of linear equations, and the second example question will be on three system of linear equations. So example number 1, solve the following system of linear equations using Cramer's rule or determinant method. So we are given with this system of linear equations. We have two equations: 3x minus 2y equals to 5, x plus 2y equals to 7. So the first step in solving the system of linear equation using Cramer's rule is first step is to represent the system of linear equations using a matrix. So first you have to obtain the matrix A, which is our coefficient matrix, 3 minus 2 and 1 2 from the equation, and our matrix X is our variables in the equation, X and Y, and matrix B is our constant values of the equation. So once you obtain these matrices, then next step is to determine the determinant of the coefficient matrix A, which is equals to 6 plus 2, which is equals to 8. So then once you obtain the determinant of this coefficient matrix A, then you have to check whether it's equals to 0 or not. Since our determinant of our coefficient matrix A is not equals to 0, we can say that this system of linear equation has a unique solution. So next step is to find the values of d1, d2 in this case. So how do you find the value of d1? d1, to obtain the value of d1, you should replace the first column values or the elements of the first column of the coefficient matrix A by the constants. For instance, in this case, our d1 matrix or determinant will be 5, 7. These are the constant of this equation, and the remaining elements of the matrix remains as it is, which is minus 2, 2, minus 2, 2. So therefore, d1 is the determinant of this matrix is equals to 24. So now, using our formula, x is equals to d1 divided by d. Therefore, it is 24 divided by 8, which is equals to 3. Therefore, we can say that the value of x in this equation should be equals to 3. Next step is to find the value of d2. So in this case, you have to replace the second column of this determinant by the constants of the linear equations we obtained, the constant matrix B. So, but the rest of the elements of the matrix A will remain same. So therefore, our d2 is equals to 3, 1, 5, 7. 5, 7 is the constant matrix. So to find the determinant of this matrix, which is equals to 21 minus 5, which is 16. So now using the formula, we have y is equals to d2 divided by d, which is equals to 16 divided by 8. Therefore, we get the value of y equals to 2. Finally, you can write down the solution as x equals to 3 and y equals to 2 for this system of the linear equation. Now let us consider the system of 3 linear equations in example 2. So solve the following system of linear equations using Cramer's rule. We are given 3 systems of linear equations. So you're asked to solve using Cramer's rule or determinant method. So our first step is to transform the system of linear equation in the form of matrix. So therefore we obtain the coefficient matrix A, which is the coefficients of the linear equations, and our matrix X, which is the variables involved in the system of linear equation, and our matrix B is the constant of the linear equations. So now you have to find the determinant of our coefficient matrix A, which is equals to -8. So therefore, our determinant of the coefficient matrix A is equals to -8, which is not equals to 0. So therefore, the system of linear equation has a unique solution. So next step is to find the values of d1, d2 and d3, and to finally compute the solution for x, y and z. So in order to find the value of d1 in the determinant, the first column of our coefficient matrix A should be replaced by the constant matrix B. So therefore we have this determinant for d1, so which is equals to -8. So according to our formula, the value of x is equals to d1 divided by d. -8 is the d1 and -8 is the determinant of the matrix. So our answer is equals to 1 for the value of x. So next you have to determine the value of d2. d2, you have to replace the second column of our coefficient matrix A by the constant matrix B, elements of the constant matrix B. So if you compute this determinant, we get the value -16. The formula to find the value of y is equals to d2 divided by d, which is -16 divided by -8, which is equals to 2. Therefore, the value of x is equals to 2. Finally, you can compute the value of D3. Replace the third column or the last column of the coefficient matrix A by the elements of the constant matrix B, and then compute the determinant of this matrix. You will get negative 16. So according to our formula, the value of z is obtained by using the formula d3 divided by d, which is negative 16 divided by negative 8, which is equals to 2. Finally, we can say that the solution for the system of linear equation is obtained when x is equals to 1, y is equals to 2, and z is equals to 2.